Hello, fifth graders. Last time we looked at this particular improper fraction, 76/17, and showed why it is equal to the mixed number 4 and 8/17. The simple answer to why they are the same is that they are the same point on the number line. The 76th 17th, if you start all the way back at 0 and just count all the 17ths, when you get to the 76th 17th, you will be 8/17 past 4. And the reason for that is that the whole number 4 is 68/17. And we have actually begun in the course of looking at fractions and improper fractions, mixed numbers, beginning with the definition of fraction, we've actually sort of already covered and talked about quite a bit adding fractions with the same denominator. One of our big topics later on will be, what if these denominators are not the same? But if you add 68/17 and 8/17, you will of course be at 76/17. And this 68/17 is the whole number 4, and plus the 8/17, and there's the justification real quickly. But I wanted to make this more concrete by actually making a 17th number line between 4 and 5. I'm not going to go all the way back to 0, but you could imagine what that would look like. And if I were to ask you on a sheet of paper to just construct some line segment of any length, like maybe most of taking up most of the paper, whether you hold it vertically or horizontally, just take a ruler and make a line segment. To divide that line segment into 17 equally sized pieces might be challenging. So how did I do this one? I did this one very easily. And the reason it was easy is because I did not draw just a random line segment. I constructed a line segment that was 51 centimeters. Now let me give you a little, very brief talk here about the difference between the customary old English and American system of measurement of inches, feet, and yards. There's another system of measurement that most of the world, almost the entire world other than the United States of America, we've been a little bit hesitant dragging our feet to go fully into the metric system like the rest of the world has. In the metric system, you start with a meter. I think I can just barely get that on the screen. Here's a meter, and it happens to be a little longer than a yard. If I hold up a yardstick in front of this meter stick, you can see down here that the yardstick falls a little short of the meter. A meter is about, I think, something like 3 inches, a little more than 3 inches longer than a yard. Well, when we're talking about inches, feet, and yards, which on this side of the meter stick, it has inches inches on it, and of course every 12 inches is a foot. So from the end here up to the 12, that's 1 foot, and then from 12 to 24 is another foot. From 24 to 36 is a 1/3 foot or 1 yard, but then of course the meter stick goes a little beyond that. Now with inches, the tradition is to divide inches into halves, quarters, eighths, sixteenths, maybe even in very precise measurement devices, maybe even down to 30 seconds or 64ths of an inch. We cut in half again, cut in half again, cut in half again. That's the tradition with inches. You can see here, halfway between the 14 and the 15, there's this big line here, which is a half. And then halfway between the 14 and the 1/2 is a quarter. And you've probably had some experience with that. But in the metric system, it's different. We don't divide into halves and then quarters and then eighths. Everything's based on powers of 10. So you can see here that the meter stick is divided into 100 equally sized pieces. The end of the stick down here is 0, and then this far end of the stick, it's hidden by the metal there, but that's 100 centimeters. The meter is divided into 100 equally sized pieces called centimeters. Now I chose to make this line segment 51 centimeters. Every meter has 100 centimeters, C-E-N-T-I, and then the word meter, M-E-T-E-R. The centi in centimeter is the same as the cents. There are 100 cents in a dollar, 100 years in a century, and 100 centimeters in a meter. When you look at 51 centimeters, you know immediately that it's a little more than half a meter. Okay, here's the meter stick. I'm holding my fingers at 50 centimeters. That's exactly half a meter because 50 hundredths, this is something we haven't gotten into yet, the reducing of a fraction. 50 over 100 simplifies down to 1/2, but you can probably appreciate that. And then just 1 centimeter beyond 50 at 51 centimeters is a little bit more than half a meter. Why did I choose 51 centimeters? Why not 50 centimeters? 51 is kind of an unusual number. Well, my goal was to make a 17th number line. So can you figure out why I used 51 centimeters? And by the way, if I had just made the line segment 17 centimeters, here's 17 centimeters between my fingers, that would be very small, and then I could have made each of the points, each of the 17ths in between 4 and 5, I could have made them 1 centimeter each, but they would have run together, it would have been too small. Why did I choose 51 centimeters? Because 3 times 17 equals 51. You should be able to appreciate that mentally, even though you haven't memorized it. 3 times 10, 30, 3 times 7, 21, and add them together. 30 and 21 make 51. So I intentionally, strategically made the line segment 51 centimeters, and then every 3 centimeters was a 17th. I think you can see them well enough. Yeah, I can see it on the screen here. So if I start at 4 and then count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, I land on the 5. It's a 17th number line. The distance between 4 and 5 has been divided into 7 equally sized pieces. And the thing that made that easy to do was I made the line segment 51 centimeters and then just held this up there and then just put a point every 3 centimeters, 3, 6, 9, and so on, all the way up to the end at 5, which was 51 centimeters. Okay, so let's count to 76 17ths, starting with 4, which is 68 17ths. 69, 70, 71, 72, 73, 74, 75, 76. This point right here is 76 17ths. It's 8 17ths past 4. It's 8 17ths past 68 17ths. Now, it's also, of course, 4 and 8 17ths. Let me now, instead of counting 69 17ths, 70 17ths, 71 17ths like before, let me just start back at 1 17th. So here's 4, 1 17th, 2 17ths, 3 17ths, 4 17ths, 5 17ths, 6 17ths, 7 17ths, 8 17ths. And there you go. There's a concrete depiction of why 76 17ths equals 4 and 8 17ths. I am going to make this a short video, but I can't resist just getting into one other aspect of fractions, something that we will be able to do. It's not that difficult. There are a few things I'll need to do to fully explain this topic, but the topic of comparing fractions. When you have 2 fractions, which one's bigger, which one's smaller? You do this from a very young age in 1st grade. You learn about the less than and the greater than symbols. I'm sure you're familiar with those. let me pause for a moment. I'm not sure if this is a realistic question, ladies and gentlemen, but let me get my head out of the way. Look at that number line from 4 to 5, and I've indicated the point that is 4 8/17. Is that number, whether you call it 76/17 or 4 8/17, let's focus on the mixed number. Is that more or less than halfway from 4 to 5? How does 8/17 compare to 1/2? Is this point closer to 4 or is it closer to 5? I will tell you that 8/17 is not equal to 1/2. I'll give you that much. 8/17 does not equal 1/2. But if you look quickly up there, it might seem to you that the 4 8/17 is about halfway between the 4 and the 5. But since it's not exactly 4 1/2, is it less or is it more? If it's less than 4 1/2, this point is closer to the 4. If it's more than 4 1/2, our point would be closer to the 5. What do you think, just based on how you look at it? Well, I honestly don't know if it's realistic to expect people. It's kind of small when you look at it on your screen, perhaps, but 8/17 is less than 1/2. So in this circle here, between the two numbers, we're going to put a less than sign. You might have learned that the alligator is hungry and wants to eat the bigger number. Okay, so here's the alligator's mouth. It has to face the 1/2. The 1/2 is greater. It's a bigger number than the 8/17, which means 1/2 is to the right of the 8/17. Now, here's something about fractions equal to 1/2. I talked earlier about fractions that equal 1. How do you recognize a fraction that's equal to 1? 2 halves, 3 thirds, 4 fourths, 5 fifths, 6 sixths, 7 sevenths, and so on. 99 99ths. 500 over 500. When the numerator is the same as the denominator, the fraction is equal to 1. Well, when is a fraction equal to 1/2? Let me give you some examples of fractions that are equal to 1/2 and see if you can figure it out. 2 fourths. 1/2 is equal to 2 fourths, which is equal to 3 sixths, 4 eighths, 5 tenths, 6 twelfths, ... Somewhere down the line there, we get to 50 hundredths. Remember before I said 50 centimeters is 1/2 of a meter? Well, that's because there are 100 centimeters in a meter, and 50 is half of 100. You notice that pattern, correct? All the fractions that are equal to 1/2, the numerator is half of the denominator. 1 is half of 2, 2 is half of 4, 3 is half of 6, 4 is half of 8, and so on. We'll explore this more when we're not actually at that topic yet, but I thought it would be interesting to check it out. And I'm actually going to get into a topic that we don't really get fully into until 6th grade. I might mention it now and then during the course of 5th grade, but let's ask this question. Is it possible for a certain number of 17ths, switch it to another color here, to exactly equal 1/2? I've told you that 8/17 is less than 1/2. Well, let me tell you something else. 9/17 is greater than 1/2. Okay? 8/17 is less than 1/2. Why? Because 8 is less than half of 17. And 9/17 is greater than a half, because the 9 is greater than half of the 17. 9 is more than half of 17. Now, it's sometimes said to younger students, maybe 5th graders, well, we can't make halves out of 17ths because Maybe you could articulate this, because 17 is an odd number. Half of an odd number is not a whole number. So sometimes teachers might say, and textbooks might not even consider the fact that 17ths could equal, that you could have some 17ths that exactly equal a half. You can, except you have to be willing to accept a kind of fraction that we really don't get into fully until 6th grade, and that is something known as a complex fraction. There is a fraction with 17 in the denominator that is exactly equal to 1/2. It's 8.5/17. Now, don't worry about this for now. You're not really going to be responsible for working with fractions like this. There's a name for it. They're called complex fractions. Not surprisingly, it's kind of complex when you're trying to consider a fraction that contains another fraction within it. But if you think about that pattern for halves, this 8.5 is half of the 17. This is a question I sometimes ask students younger than you. If I ask, say, a 3rd or 4th grader, what's half of 16? They usually can tell me 8 pretty quickly. What's half of 18? They can tell me 9 pretty quickly, 3rd and 4th graders. Certainly 4th graders can do that. Well, sometimes they're stumped, though, if I ask, what's half of 17? Well, half of 17 is 8.5. 8.5 plus 8.5 is 17, because 8 and 8 is 16, and 1/2 plus 1/2 is 1. There you go. We're getting into adding mixed numbers just now. 8.5 plus 8.5 is 17, so the 8.5 is half of 17. So I guess that's it. It's a little longer than I expected, but once I get started, sometimes I find it difficult to stop. But this is a little bit more about 76/17 being exactly the same as 4 and 8/17. There's the point on the number line that they both are. Both of these points they're on top of each other right there, and it's a little bit less than halfway between the 4 and the 5. Now, this is the 17th number line, but based on this right here, which you're not really responsible for yet, the fact that 8.5/17 equals 1/2, well, this is 8/17 past 4, this is 9/17 past 4. If we go right in the middle between them, that would be 8.5/17. And does that, where that red arrow is pointing right there, does that look like it's halfway between the 4 and the 5? It should. The 4 and 8/17 is a little bit to the left of it, okay? Halfway between 8/17 and 9/17 would be 8.5/17, and that is 1/2. All right. So long for now, 5th graders.